Hello everyone. Today we'll be looking at the quick solutions to the chemistry section of All India Akash Test Series JEE Main 2019 Test 10 Code A and B. So let's start with the first question. Let us start with question number 31. Among the following compounds, so students, we have been given 4 different compounds and the examiner seems to be interested in the compound which resists the formation of a carbocation on reaction with H+. Students, what is going to happen is this H+ will attack the lone pairs over oxygen and convert into OH2+, which is a good leaving group, and make it leave. Okay. So if we try and figure out the carbocations which will be formed from the compounds given, the first structure is going to lead to the formation of this carbocation. So this is anti-aromatic, students. If we talk about the second compound is going to generate this carbocation, which is aromatic. If we talk about the third compound is going to generate cyclopropyl methyl carbocation, which is also stable because of the dancing resonance. And if we talk about the fourth compound is going to generate the tropylium cation, which is also aromatic in nature. So out of the given options, we can clearly see that the first compound will generate an anti-aromatic compound, and as such it will resist the dehydration on reaction with H+. So students, for this question we have to mark the correct answer as option 1. Let us look at the next question. Question number 32. So we have been given a reaction sequence and the examiner seems to be interested in the end product B which is formed. Okay. So if we talk about the reagent set which is given to us, we have an alcohol and BF3. This BF3 is a Lewis acid, and this Lewis acid will attack this OH and make it leave, generating a carbocation over here. So we are going to have the electrophilic aromatic substitution reaction of this carbocation generated, and it is going to lead to the formation of this structure. Now it is allowed to react with NBS and CCl4. So the NBS in CCl4 is a allylic or benzylic brominator. So this will lead to the substitution of a Br radical at the benzylic position in this case, which is represented by the arrow. So we are going to have the formation of this structure. Okay. So if you look at the options which are given to us, we can clearly see that we have to mark the third option as the correct answer to this question. Let us look at the next question. Let us look at question number 33 now, students, in the following conversion. So we have been given a reaction in which a halobenzene is allowed to react with OH- and the nucleophilic aromatic substitution is taking place. So this is an ArSN2 reaction, students, and some statements regarding to the reaction are given to us and we have to comment on the statement which is incorrect. So if we try and figure out the mechanism of this reaction, the nucleophile will attack the substrate at the ipso position, that is at the position where the halogen is present, and this will lead to the shifting of the pi bond at this position. So we're going to have the formation of an intermediate which is represented by this structure. Now students, the negative charge which is created here can be stabilized by the -I as well as the -M of the nitro group. Now this negative charge thus created can also undergo resonance. So this can undergo resonance to reach the para position of the halogen. And the negative charge is also again stabilized by the presence of NO2 group over here. So this step is the RDS step, students, in which the aromaticity is lost. So the attack of the nucleophile leading to the formation of this intermediate is the RDS step. Okay. So if you look at the statements which are given to us, the first statement talks about the redetermining step involved the departure of leaving group. This is incorrect, students. The redetermining step includes the attack of the nucleophile. So if you talk about the second statement now, redetermining step involves the formation of carbanion. This is correct, students. In the RDS, there is loss of aromaticity and there is a formation of the carbanion as depicted in the structure above. So the second statement is correct. Let us talk about the third option now. Presence of nitro group at ortho and para position favors the rate of reaction. This statement is correct, students. As we had already seen that RDA step involved the attack of the nucleophile and it led to the formation of an carbon ion. So the carbon ion generated shall reach the ortho and the para position of where the halogen was located, and the carbon ion will be stabilized by the presence of NO2 groups, thus increasing the rate of reaction. So the third statement is also correct. If you talk about the fourth statement now, rate determining step involve formation of carbon ion and presence of nitro group at ortho and para position favors the rate of reaction. So both of these statements are correct, students. We've already seen them in the second and the third option respectively. So for this question, students, we have to select the incorrect statement and we have to mark the first option as the correct answer to question number 33. Let us look at the next question. Question number 34. So we have been given two reactions in which benzoic acid and anisole is allowed to undergo the Birch reduction. So students, if we talk about the products formed due to Birch reduction, if there is a deactivating group present, we have the formation of this compound where G is electron withdrawing group. And if we have a electron donating group, we can call it G star. This is electron donating group, EDG. So this will lead to the formation of. So if we look at the groups which are attached in the first reaction, there is COOH, which is carboxylic acid. This is an EWG. So it will lead to the formation of this type of structure in which the G will be replaced by COH. If you talk about the second reaction, in the second reaction we have methoxy group, which is electron donating group, and we are going to have product of this form where G star will be replaced with OCH3. So if you look at the options which are given to us, we can clearly see that we have to select the first option as the correct answer. Let us look at the next question. Question number 35. In the given reaction sequence, so we have been given a substrate which is allowed to react with KMnO4 in the hot acidic conditions to give us the product A. So students, if this hot acidic KMnO4 finds any benzylic hydrogen, it is going to convert the alkyl group into COH. So we have two alkyl groups attached to the benzene ring and both of them have benzylic hydrogens. So the KMnO4 will convert these groups into COH. So we're going to have the formation of phthalic acid, in which the COH groups are present at the ortho position. So this is the correct structure of compound A. If we talk about the compound B, which is formed by the free radical bromination of this compound, so this is also going to lead to the substitution at the benzylic position. So this is going to lead to the formation of this structure. So if you look at the options which are given to us, we have to select the correct statements. And the first option says both A and B are optically active. A is not optically active, students. This is incorrect. If you talk about the second structure, both A and B contain chiral carbon. So we can clearly see that the compound B has a chiral carbon, but the compound A does not have any chiral carbon. So this is also incorrect, students. If you look at the third statement now, A contains chiral carbon while B does not contain chiral carbon. This is also incorrect, students. It is the other way around. Compound B, it contains chiral carbon, whereas the compound A, it does not contain any chiral carbon. So which is given correctly in the fourth option. So students, for this question, we have to select the fourth option as the correct answer. Let us look at the next question.